So guys, our topic today, I will talk about steel building, mainly steel beams and steel columns. Sometimes your structure or your building is made from steel. So we have a column, we have main girder, we have floor girders or floor beams, and we have purlins or something called joists or something like this. Anyway, so right now I will talk about different structure. It's not different, it's not a big deal, but we have different elements. So today I will start to talk about something called column. What we covered before, we covered only trusses. So we have tension member and we have compression member. We learned how to design this member, how to design this member, how to design the connection between these members. That's right. How to draw the layout for trusses. But today I will talk about steel building. So for steel building, probably we don't have truss. We have column, which is a typical building, like a concrete structure. We have a column. We have before column, we have foundation. And we have column. And we have beams. And we have a slab. That makes sense? So this structure, under this column, we have foundation. I think we have footing. And then your column, and then beams, and then you have concrete. This is the typical steel building. So today or this week and the next week, I'm going to design beams and the columns. Because last semester, you learned how to design foundation, how to design slab. That's right. Okay. So beams are a structural member that supports transverse loads and are therefore subjected to mainly flexural or bending moment. Most of the time, 90%, we are using W shape. We are using wide flange, I beam, W shape. Sometimes we are using S. Here is the W shape, I beam, looks like this. Like this one. Design of beams is covered in AISC specification under two chapters. The first one, how to design this beam under the effect of bending, flexure, and under the effect of shear. If you have a beam and this beam under the effect of load, for example, distributed load, from structure analysis, we learned that we have shear force diagram and we have bending moment diagram. So if you decided to design a beam, you have to design this beam, this steel beam, against shear and against bending moment. And also we will cover columns. Columns and under the effect of axial compressive force. Before starting, I need you to be familiar what are the different types of beam. Sometimes your beam is called floor beam. It's supported between another two main girder or another two main beams. And this beam is still supporting another beams. If you go back to this photo, which one is the floor beam? What do you think? Which one is floor beam? This one. This one. Called floor beam. Why? It's supported by another beam, and at the same time, this beam is supporting another beams. That makes sense? So we have something called a floor beam, is a major beam of a floor system, usually supporting joints in a building, a transverse beam in a bridge floor. Anyway, we have something else called girder. Girder is a beam, but its main beam supported directly on columns. So I believe the main girder here will be this one. This one will be main girder. Do you know why? Because this beam is supported directly on column. If you have a beam like this beam will be called girder. The third one called joist. Joist is a beam, but we call it joist because it's the last level of secondary beams. Can you watch to this floor? These secondary beams is supported by this transverse beam, and the transverse beam is supported by this main girder. So the last level of secondary beams can be called joist. So guys, remember, this one is beam, this one is a beam, this one is a beam. But the different function of each one, we can call it with a different name. Okay? But at the end, they are beams. So the joist here in this photo will be this one, called joist. They're still a beam, but we can call them joist. So the main system for this structure, it's very important. Guys, it's very important to understand what is the main system for any structure. If you can understand it, you can solve it. So these secondary beams, which called joist, is supported by these floor beams. The floor beams is still secondary also. The floor beams are supported by the main girder. The main girder is supported by directly on columns. That makes sense? Anybody know this joist is supporting what? Supporting floor construction. If you have corrugated sheet, if you have concrete slab, if you have any covering, anything at the top is supported by joist. Joist is supported by floor beam. Floor beam is supported by main girder. Main girder is supported by columns. Sometimes this beam or this steel beam called lintels. Lintels. This term is very important for professional engineer exam. Guys, if you have door in a wall, here is the wall of brick, like this. To make sure you are constructing this door correctly, we have to construct here a beam. This beam can be concrete beam or steel beam. Anyway, this beam will be called lintel. That makes sense? So in our course, this beam is a steel beam covering a door or opening window, it can be called lintel. Does that make sense? So beam members used to carry, because this beam is carrying a wall, over wall opening like door or window. Does that make sense? We have a beam called Berlin. If you have inclined floor and you have trusses, the connection between the main system with a secondary beam called Berlin that we learned before. So if you have a roof, sloped roof. So these Berlin are supported by trusses. If we don't have truss and we have inclined beam like this beam at this time can be called rafter. But this case and this case, if you have a sloped roof, so the main beam can be called rafter, the secondary beam can be called Berlin. Rafter or Berlin or lintel or joist or girder or floor beams, all of them are beams. All of them have shear force diagram and the bending moment diagram. All of them will be designed in the same way. Okay? We have different names. If you have a main system, here is the main system for the truss, the next main system, the next main system. If you construct a member connecting between this column on this side or this side, we can call it girt or side girt. Believe me, side girts are beams also. If you construct a wall, the part of the wall above this beam is supported by this beam. And this beam or this side girt is supported by this column and this column of the main system. So side girt is a beam. Sometimes you have a bridge, steel bridge. So we have truss on this side and another truss on the other side. This can be called beam, but we can call it stringers. Stringers. Okay, so stringers is a beam, girts is a beam, rafter is a beam, Berlin is a beam, lintels is a beam, joist is a beam, girder is a beam, floor beams, beam. But we have different functions, but finally at the end, they are considered beams. Any questions so far? Any questions so far? Okay. Guys, for floor, steel floor, we don't like two-way slab. We like one-way slab because this will help you more in your capstone project. What you mean by two-way slab and one-way slab? I mean, for the project, we have the location of columns. For some reason, we have these columns. As you remember, we don't like columns to make any issue with the architectural design. So what do you think? Do you like to put beams between these columns? And that's all? Or we need to add secondary beam inside? Okay, it's a good question. If you put only 4 beams between columns, that means we have this length and this length. If you divide longer of this panel by shorter of this panel and your value smaller than 2, you are talking about two-way slab. That means part of this slab will be supported by this beam, another part will be supported by this beam, another part supported by this beam, and the remaining with this beam. Do you remember that? Do you remember something like this? We don't like this. In steel structure, we don't like this. We would like something different. We would like, if you divide longer by shorter, we would like this value to be greater than 2. Why? To be one-way slab. So I will put beams, which called girders, between columns, and then I will put floor beams like this, and then probably if these spans are too long, I will put secondary beams which called joists like this. So if you are looking for this little panel, if you divide the longer side by the shorter side, should be greater than 2. That means this slab is one-way slab. That makes sense? So do you remember what's going on with the one-way slab? You have to divide this one. So half of this slab is supported by this beam, and the other half is supported by this beam. That's it. That's it. We are done. The same here. Half for this part of the beam, half for this part. The same here, half and half. And we covered all of this stuff before. Do you remember? So the same meaning here. So during your capstone project, if you don't have a statical system and you would like to locate the beams, I highly suggest first, you need to locate the locations of columns without making any disturbance with any architectural design. The next step, you need to connect these beams, these columns by main girder. The next step, you need to divide this rectangle with another beams to make your slab to be one-way slab. We recommend this. I didn't say this one is wrong. I didn't say this, but we don't like it. So guys, many floor systems consist of reinforced concrete slab. That makes sense. Your slab is reinforced concrete slab supported on rectangular grid of beams. Such a grid of beams reduces the span of the slab and thus permits the designer to reduce the slab thickness. This statical system will give you smaller thickness of slab and a smaller cost. The distribution of floor loads on floor beams is based on the geometric configuration of the beams forming the grid. What does it mean? For this plan, we have columns. these columns are supported first. I'm sorry, these columns are connected first with main girder, making grid like this. Then each panel will be L1 times L3 or L2 or whatever. Longer divide shorter, still two-way slab. We don't like this. So the next step, I draw joists. These joists divided the concrete slab to smaller panel, like this one. If you divide the longer by the shorter, you should get a number greater than 2. So we have one-way slab. If you would like to make loading, okay, this beam, for example, will support from center line to center line. That makes sense? So this beam will support this area of slab. So this little beam will be simply supported under the effect of uniform distributed load. How much? I can get it from this area assigned to this beam. Once you get the load on this beam, I can draw the shear force diagram. I can draw the bending moment diagram. Anybody can tell me, or do you expect what is the loading on this main girder? This main girder, if you assume it as a simple beam between the two columns, this column and this column, so what is the shape of load? Anybody can tell me, what do you expect? Do you have distributed load on this main girder, or do you have what? Any answer? Anybody can tell me what is the shape of load on this main girder? Thank you of the joist, point load. Thank you so much. Yes, we have a beam. 1, 2, 3, 4. The same also from the other side at the same location. 1, 2, 3, 4. So we have 1, 2, 3, 4. 4 concentrated load at this location. Anybody can tell me what is the value of this concentrated load? Yes, I can. Reaction from this one, double 2. Do you know why double 2? Because this reaction, which is R, coming from this joist only at this point. Remember, we have another joist on the other side at the same location. So this beam at this location has 2R. If you can figure out this value, I can draw shear force diagram. I can draw bending moment diagram. Guys, remember, I cannot design without these diagrams. I cannot design any beam without these diagrams. Just to remind you for something. If you are talking about dead load, remember that the beam has on weight. We didn't design it yet, so we can assume it. You can assume between 50 to 200 pounds per foot. One of you will ask me, hey, which value, 50 or 200? Okay, you can decide this. If you are designing main girder like this one, I expect this beam will be big beam. So I believe the on weight will be high, 100, 150, 200. But if you are talking about joist, which is a secondary beam, so I expect this beam will be little beam. So the on weight will be around 50, 60, maximum 70. If you go back to the previous photo, can you see? Can you see the big difference between main girder cross section and the floor beam and the joist? We have a big difference. So I believe the weight assumed for this one will be high. The weight assumed for this one will be in the middle. The weight assumed for this one will be very small. So we have a range between 50 and 200. Go ahead and select based on what do you think. These beams are supporting something, probably concrete slab, probably we have corrugated steel sheet, that's it. So based on what is the floor covering, you can decide if it's a corrugated steel sheet. We have a range 25 to 50 pound per square feet. If you have a concrete slab, okay, we learned it before. If you would like to get the value or the weight of the concrete slab per unit per square feet, you have to multiply gamma concrete by thickness of concrete. Remember, gamma concrete equal 150 pound per cubic feet. We covered this in details last semester, I think. Okay, so what is the uniform load on the beam? Okay, you can add the on weight. No. You can add you can add the on weight of the beam plus covering weight times spacing, because each beam is supporting from center line to center line. So this distance will be called spacing between this beam and this beam and this beam. That makes sense? So if you multiply this covering, anyway, corrugated sheet or concrete slab, this covering by spacing and add them to the on weight of the beam that you assumed, then your beam will be under the effect of uniform distributed load for dead. For life load, if you have a residential building and you are talking about floors, okay, what is the main function of this building? Is it hospital? Is it office building? Is it a school? University building? So based on the function of the building, we can use American Society of Civil Engineers that we learned last semester. Do you remember? I provided you with a table based on the function of the building. I can decide what is the value of life load. If you are talking about sloped or flat, but it's roof, nobody is living there. It's roof. So we have two situations. Do you remember? When you have access, so we will assume life load equal 30. If you don't have access, we can assume it 15. But if it's sloped, the inclined angle 10 degree or smaller. Inclined angle for this sloped roof, this angle 10 degree or less. If the sloping angle greater than 10, we have two situations. 15 minus 0.5 for each degree greater than 10, and the life load must be 8.5 or greater. Anyway, you decided the value of the life load. Go ahead and multiply this value of life load by spacing to figure out the uniform load of life load on the beam. Once you decided what is the value of life load, what is the value of dead load, okay, W ultimate equal 1.2 dead load plus 1.6 life load. Once you get the ultimate load, you can draw shear force diagram or bending moment diagram based on your learning on structure analysis course, or you can use RISA 2D. Let's do an example. Let's do an example. Do you have any question? Any question so far? Yes, yes. If you would like to give me results, you have two options. You can do it with your hand calculation. If you are using a software like Risa, you have to show me these results by snipping them. Okay? We have a floor system of classroom, probably in a school, and we have classroom floor system consists of 3-inch thickness reinforced concrete slab. So this slab has a thickness, it's 4, not 3, I'm sorry, it's 4, like this one. Supported by steel beams. Okay, if the weight of each steel beam 62, okay, we don't need to assume what is the own weight of the beam because it's a given. Draw the shear force and the bending moment diagram due to the ultimate applied load. Let's start first with the dead load. For dead load of the beam, we have two parts. On weight of the beam, which is given in this problem, 62 pound per foot. If this value is not given, we have a range here from 50 to 200 pound per foot. You can choose between this range. The second part of the dead load is weight of slab. This weight of slab equal gamma concrete TS or T concrete or T slab. The value of gamma is 150. The thickness of this slab is 4-inch. You have to divide it by 12 to be in feet. We have 150 times 4 divide 12. This value will equal 50 pound per square feet. Be careful. You are multiplying gamma, which is pound per cubic feet, by thickness, which is in feet, so the result will be pound per square feet. I cannot add this value to this value right now. Do you know why? Because this one is pound in per foot, this one is pound per square foot. So the final dead load on the beam equal W on weight plus W of slab time spacing between girders or beams. Because each beam is supporting a part of the slab from center line to center line. Can you tell me what is the length of this width? 12, which is the spacing between girders. So the final value of dead load equal 62 plus 50 times 12. This one is still pound per foot. This one is pound per square foot. And you multiplied it by foot. So your final answer will be 662 pound per foot, which is uniform load. Because this structure is a classroom, so if you go back to previous semester, concrete design, we have a table here called the live load. If you have classroom, okay, let's start to search about schools. Schools, here you go. For schools, classroom, what is the value of live load? 40 pound per square feet. So the value of live load equal 40 pound per square foot, because your function, the function of the building is classroom. So the final value of live load equal 40 times. Remember, this 40 on the whole slab. But each beam is supporting from center line to center line. So if you multiply this 40 by 12, you can get the value of the live load as pound per foot. What is the value of ultimate? Ultimate load 1.2 W dead load plus 1.6 W live load. So the final value will be 1,562.4 pound per foot. At this moment, I would like to convert it to be 1.6 kib per foot will be better. Convert it from pound to kib. Any question? I believe this example is not new for you because we covered this system before in concrete design. Then finally, we have a beam. I'm not sure what is the length. Is it given or not? It's not given. The length of this beam is not given. Anyway, L, this beam under the effect of uniform distributed load, W ultimate. How much? 1.6 kib per foot. We have a reaction here, WL divide 2. We have another reaction here, WL divide 2. We have shear, looks like this. This value equal to this reaction, this value equal to this reaction. We have a bending moment diagram. This value of moment equal WL square divide 8. So here is the shear force diagram. Here is the bending moment diagram. Most of the steel beams are simply supported. Most of them under the effect of uniform distributed load. So most of the diagrams will be like this one and this one for shear and the bending moment diagrams. So your W here is 1.6. Based on the length of this beam, I can figure out the reaction, which equal to this value of shear. Based on the W, 1.6, and the L and the 8, I can figure out the maximum moment. So I can, this value, which is M ultimate moment, the applied ultimate moment. One more example. One more example. We have a floor system of a hospital. Consists of 4-inch thick reinforced concrete slab supported by steel beams W24 times 55. These beams are wide shape W24 times 55. Calculate the ultimate applied load on each beam in the floor. We have joist and we have main girder. Anyway, before starting to do anything, we would like to say what is the value of dead load. Do you remember? For dead load, we have on weight of the beam. Do you think the on weight is given? Guys, do you think the on weight of the beam is given, or I need to assume it? Any answer? Any help? We have something we need to understand. Do you think the on weight is given? If it's given, how much? Thank you, Oliver. Thank you. It's a good point. W 24 times 55, you have to remember. I told you in the first meeting in this course, for W shape, 24 times 55, these numbers have a meaning. The first number, 24, is the depth of the cross section, 24 inch. 55, which is the second number, means the weight of the unit length, 1 foot, equal 55. So the on weight of this beam is 55 pounds per foot. Does that make sense? You have to remember all of this information. Keep it in your mind. So the on weight is not given like the previous one. The previous one said the on weight of the beam is 62. It's direct information. But right now, he didn't give us the on weight, but he gave us something else. He gave us the beam itself, 24 times 55. So the on weight of the beam equal 55 pounds per foot. What is the weight of slab? Equal gamma concrete T slab. 150 times 4 divided 12 equal 50. Yes, 50 pound per square feet. Let's start with this beam. For example, so the W dead load equal 55 plus 50 time spacing. This beam is supporting part of the slab from center line to center line. So what is the width here? The total length is 30, 3 spacing, so each one will be 10 feet. So 50 times 10. Your value will be 555 pounds per foot. That makes sense? For live load, what is the value of live load? This structure is a hospital. So if you open this table for hospital, and we assumed it's a patient room, for example, or operating rooms or corridors above the first floor, based on what is the main function of this part of the building, we can decide which live load. Okay, we can assume it 40 pound per square feet. So the value of live load on this beam equal this 40 times 10 equal 400 pound per foot. Once you get a value for live load and a value for dead load, I can figure out the value of ultimate load. 1.2 dead, 1.6 live. And probably it will be the perfect time to convert from pound to keb, equal 1.3 keb per pound, per foot. Just a second. Okay. So this beam, the length of this beam equal 40. We have a beam simply supported with length equal 40 and uniform ultimate distributed load 1.3 kb per foot. So I can figure out what are the reactions. WL divide 2. (26 kb). 26 kb. So your shear force diagram, your bending moment diagram, shear force diagram looks like 26, 26, negative, positive. So the maximum value of shear V ultimate equal 26 kb. I'm going to design the beam based on this value. For bending moment diagram, we have a parabola. The maximum value of moment, WL squared divide 8. This value, (260 kb foot). So the value of M ultimate, 260 kb foot. I am ready to design. I am ready to design. Okay, I am done with this beam and this beam because all of them will be the same. Anybody can tell me what is the difference between these beams and this one, this one, this one, this one? What is the main difference? Or will be the same? What do you think? Thank you. Thank you. The only difference, if you are talking about this called interior beams. If you are talking about exterior or edge beams, nothing will be changed. The same span 40, the same uniform load, the only difference this value 1.3, it will be 0.65 kb per foot, half value. Do you know why? Because this beam is supporting from this center line, which is this one only. However, the interior beam is supporting from both sides, so it will be doubled. So this one supporting half this one. It's not exactly half because we already, the on weight should be the same, no difference. We cannot divide it by 2, but anyway, we can assume it half. Okay, can you tell me what is the loading on this main girder? This main girder looks like a beam supported here on a column and another column. The total length is 30 feet. This is span from here to here is 30. Supporting here a concentrated load, a concentrated load, a concentrated load, concentrated load. If you are talking about this interior one, let's do this interior one. So if you are talking about this one, so we have two concentrated load. This distance will be 10 feet. 10 feet, 10 feet. What is the value here? What do you think? I think this value will be 52 kip. Do you know why? Because 26, which is a reaction coming from this beam only at this location, we have 26. From the other beam on the other side, we have another 26. So the total concentrated load at this location will be 26 times 2. So we have 52. You can figure out the reactions. It will be 52, and this reaction will be 52. And you can figure out the shear force diagram will be like this. 52, 52, and the bending moment diagram will look like trapezoid. And this value 520. This reaction times this distance. If you cannot figure out what is the shear force diagram or bending moment diagram due to the effect of these loads, okay, go ahead and use RISA to give you the shear force diagram and the bending moment diagram. If you cannot. Any questions so far? So it's very easy. Just understand how can I do loading. We decided that, to summarize what we learned today, we have different meaning of beams. Sometimes it's a floor beam, girder, joist, lintel, purlin, rafter, girth, stringers. All of them are beams. The main concept, each beam is supporting from center line to center line. Okay, once you get the loading, you can draw the shear force and the bending moment diagram. I'm giving you a few numbers for on weight of the beam, if you have corrugated sheet or if you have concrete slab, and if you have live load. This number will help you to figure out what is the final distributed load on the beam. Next time, I will go through inclined beam, what you mean by inclined beam, and the column, and then I will go through RISA floor. If we have floor building with a steel structure, how can we do it with RISA? Do you think we have something different or everything will be the same? We will cover this next meeting.